Assalamu alaikum wa rahmatullahi wa barakatuhu. Friends, welcome back to my channel. In this session we will discuss soft start circuit of this LG 4-ton inverter AC board. In previous videos we discussed the composition of the board, EMI circuit, the safety parameters. Then we repaired this power supply section, how this low voltage power supply works, and in last video we discussed how this standby circuit works. When this circuit is powered on, it receives power on command from pin number 7. At that time this IC will turn on. It will provide 15 volt regulated here, then this 5 volt regulator, it will provide 5 volt here. After that processor will turn on, and then it will turn on this soft starter circuit, that is Inrush protection circuit. Today we will see how this circuit is composed. Low current input terminal, it will power on just only this low power section, that is this one. But at these two connectors it receives high current input. This resistor, this small relay, power relay, current sense IC. After that these voltage will reach to bridge rectifier input terminal. If we check here, this is input terminal, line, neutral. This point it is reaching directly here at bridge rectifier input. And if we check this terminal, that is this one, it is reaching at this point, that is contact of this power relay. It is T92 series, T92 S7D 12-12, 30 ampere relay. Normally this relay is off. Then these voltage will reach here at this point. From here to here we have this small relay, that is this one. When it will turn on, when the processor will turn on, processor will write command on this IC. It is KID 65004. It will drive this relay. This relay will turn on. It will connect these 220 volt here at this resistor, 20 watt 470 ohm resistor. Second end of this resistor is connected at this point, jumpered from inside of the board at this point, and this point is passing here now, and it is connected to AC 710 IC. It is just only a shunt resistance. It has very precise circuit that will monitor the current. It is programmable. We can set limit and it will detect that current. In case of any overcurrent or what is the real-time current, it will monitor. Then it will pass these voltage here at this point, and these will reach to bridge rectifier. Then here is voltage sense line. This current sense how much current is flowing. It will go to this PFC controller and it will go to microcontroller here. We will discuss when we will discuss this section. Line, neutral. This line is reaching to this power relay, that is 30 ampere relay connector. Then it is reaching to the small relay, that is also powered off. This one is 30 ampere relay and this is small relay for soft start. And in a series of this relay there is 470R 20 watt resistor. It is connected at this point. Then it is reaching to AC 710. We will discuss just only the shunt section here, the shunt resistance here. After that these voltage are reaching to bridge rectifier. This 30 ampere relay, this relay, it have winding. This relay, its winding is here. and this relay, small relay, its winding is here. We can see one point of this relay and one point of this relay is connected together. This 30 ampere relay, it is connected to ground. This point, that is this one, and this point, if you see, these are reaching here. This point is reaching here and this winding is reaching at this point. This relay, this end, is reaching to this IC, that is KID 65004. It is Darlington transistor driver. First pin in this corner, 1, 2, 3, 4, 5, 6, 7, 8. Pin number 9 is driving this relay and pin number 10 is driving this relay. When pin number 9 will turn on, at that time it will turn on this relay. This relay, KID 65004, pin number 9. This pin number 10. When this relay will turn on, at that time it will close its contacts. That are these two contacts. When it will contact, the voltage from here will pass to this point and it will go to resistor second end. This end is connected here and this end is connected to this current sense IC at this point, and its output side is connected to this bridge rectifier, this point. So we can say normally this point is off. To pass the current we have two paths from here. The first path, that is here to this point, then this IC, then here. That is from here. Why we need this current? Because in the output of bridge rectifier, when this reactor is connected here, it will pass these rectified voltage through reactor to this point, and then these are reaching to these rectifiers and IGBTs, and after that these voltage are reaching to positive terminal of these capacitors. So we have huge capacitor bank. It will provide heavy surge at input circuit here, because 4 capacitors of 560 microfarad, 450 volt, these will draw too much current. Might be our circuit breaker will trip, our bridge rectifier can damage. So anything may happen. To protect from that inrush current, first this resistor will come in series, positive, negative. These positive voltage, these are reaching output reactor. Then we have negative line, IGBTs. These are capacitors here. When this circuit will turn on, at that time in positive line this resistor will remain in circuit, so that it will allow a very slow charging current. When the voltage will start to increase at capacitor bank, at that time this circuit, it will provide voltage value to the microcontroller. Then the voltage will reach at safe limits which are defined in the program. At that time it will turn on this relay, this 30 ampere power relay, When this relay will turn on, it will provide direct voltage to this current sense IC and it will provide to bridge rectifier. At that time, the capacitor will charge at rated current, the normal current. The basic function of this circuit is to protect the circuit from any damage during the charging time of these capacitors. In upcoming session, we will apply power and we will check it in detail, and we will monitor the response of the circuit, how the relays are turning on step by step. In the first step, this relay will turn on and then it will wait until the voltage are reached at specific voltage value. Then the microcontroller will turn on this relay. After that, when the voltage are maintained, and it will receive power on command from this communication circuit, from these optocouplers, then this microcontroller will issue command to this PFC circuit to build the voltage at rated voltage to drive the compressor. If you enjoyed this video, hit the like button. If you have any question, please write in the comments. Thanks for watching.